The bond length and bond angles in the molecules of methane, ammonia, and water are represented below. What causes this trend in the bond angle shown? All right. So we can see that methane actually has, if I have to draw it nicely, all right, methane actually has 4 bond pairs and 4 bond pairs. I made it right. 4 bond pairs, right? Ammonia actually has, these are actually H's. Actually, ammonia has 3 bond pairs and 1 lone pair. Right? Water actually has 2 lone pair and 2 bond pair. 2 lone pair and 2 bond pair. Alright. So I guess you already know that lone pair repulsion. I can write down repulsion first. Lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion. Right? So it goes to show that why this angle is smaller. Because if there are more lone pairs, they will repel more and they push the bond pairs closer. Okay, they push the bond pair closer, so the angle will be smaller. So 3 is actually correct. Non-bonding electron pair refers to lone pair. Okay, lone pair bond pair repulsion is greater than bonding electron pair bonding, so it's bond pair. Right? So which means actually this statement is definitely correct. Okay, let's look at 1. Increasing repulsion between hydrogen atoms as the bond length increases. We've never taught you this before. This is definitely not true. Okay, the number of non-bonding electron pairs, which means the lone pairs. The number of lone pairs of the central atom in the molecule will actually determine the bond angle. You're right. Because if there are more lone pairs, they will push the bond pairs even closer. Is okay? They'll push the bond pairs even closer. So 2 is definitely also correct. Okay, so very quickly, the bond angle, all right, is dependent on not just it depends on the number of lone pairs that you have. Okay, and another concept is the lone pair repulsion is greater than lone pair bond pair, greater than bond pair. Right, so it pushes all the bond pairs closer. All right, so this answer would be C.